is watching this fantastic video. I would like to take this opportunity to welcome you. I'm very happy to have all of you national and international viewers who are watching these programs elsewhere in the world. You're warmly welcome to enjoy the contents that we are creating for undergraduate students. My name is Olenjolai&Nek, TAYAI, no single. Simply just call me Olenjolai. I thank God for His own gift of teaching. I'm a teacher who is going to teach you the beauty of high engineering mathematics and scientific mathematics in this program for undergraduate students. Again, I thank God by His own gift that He called me to be His own electronics and telecommunication engineer, that electrical engineer and computer scientist. So when I'm teaching you these concepts of high engineering mathematics, remember that also I thank God by His grace have a good backgrounds of engineering. So I'm speaking with people who have the same mindset, who have the real focus to see how we apply science in order to solve real life problems. So I would like to take this opportunity before I go into further of this lecture 3 of Advanced Calculus. I would like to take this opportunity to welcome you into our online undergraduate Polytechnic Institute of Tanzania OLENJOLAIM. Simultaneously, because I'm teaching also mathematics, I would like to welcome you into one of our official YouTube channel that we're training undergraduate students that called the Online Undergrad Institute of Tanzania OLENJOLAIM. So, okay, I know that you are possibly just roaming around and you're finding the particular solutions for your problems, especially in the process of learning. Well, you have tried so many different ways and possibly you have given up and you dislike at all the beauty, you dislike at all the high engineering mathematics and scientific mathematics. But I want to tell you that one thing, you have never tried to be an active student of Online Undergraduate Polytechnic Institute of Tanzania, but you can try right now, okay? So I ask you that please pay attention, join me in this program, and then you will be transformed from one stage of understanding to another level of understanding. I'm from Tanzania, I'm a Tanzanian, and also I'm doing this program for Tanzania. This is our national flag. So I really love my beautiful country, and I dedicate these programs because I will be teaching according to the curriculums of National Council for Technical Education, this course of Advanced Calculus, as I told you earlier, or yes, in the beginning. So what the vision that we have, because Proverbs 20, the book of Proverbs 20, chapter 29, the book of Proverbs chapter 29, verse 18 say that where there is no vision, people perish. So if you don't have vision in Online Undergraduate Polytechnic Institute of Tanzania, we are going to perish. We are not ready for that. So I would like to declare this vision in the mind of our students so that they have to bear and they have to join us and be active and we have to fight together until we achieve it. So what is the vision of Online Undergraduate Polytechnic Institute of Tanzania? That's a good question. Wow. So this is the vision in your mind that we are here in order to train and teach undergraduate students to extract knowledge, understanding, and wisdom from the fundamental course of fundamental modules and even the other core modules, and combine with the knowledge, understanding, and wisdom that we are going to teach them to extract it from the Word of God written in the Holy Bible. So you have to make sure that you concentrate in order to solve real life problems. So our vision have 4 parts: extracting knowledge, understanding, and wisdom from the classroom instructions, extracting knowledge and wisdom from the Holy Bible, and then combining these 2 knowledge. And the 4th part is actually solving real life problems. You are undergraduate student, and actually that you are being trained on how you apply the particular knowledge on solving engineering problems in the real life. So that's the main objective. The main objective of Online Undergraduate Polytechnic Institute of Tanzania is to see our continuing and even our graduate students solving real life problems. We have so many specific objectives. One of the specific objectives to prepare you to be to do well in your continuous assessment, to prepare you also to do well in your final exams or university exam in high engineering and scientific mathematics. So we ask you to join us in order to go into too much details of this content. So we have so many departments. One of the departments is called Departments of Higher Engineering and Scientific Mathematics. The modules is called Advanced Calculus. The area of study is called the first. This course is being taught, or modules is being taught to the first or second year undergraduate students, or we call it NTA level 7. And we are in chapter 1, which is called the gamma and beta function. And today we are going to focus on the lecture 3, which is properties of gamma functions. So you have to stay focused in this program. So again, before we go into too much details, I would like also to share with you the good news that also we do have online undergraduate library, which is called the OUL. So let's welcome all our undergraduate students in our online library, where you can order some of the contents which are very important, which can help you on process of learning. We have engineering mathematics book that by J.I. Strauss. We don't have a sample, but you can order, and actually that you can order this excellent book for undergraduate students, because we really recommend it. I used myself when I was doing my undergraduate studies at the National Institute of Technology. So you can order this excellent book for you with the price of 85,000 Tanzanian shillings. And also we have another book we call Engineering Mathematics with the price of 60,000 Tanzanian shillings. And we can ship to you, or we can send it to you, we can transfer it to you, we can send it to you in all 31 regions of the United Republic of Tanzania. But again, we have another weapon, which we call the certificate calculator. This is Casio function 981 MS. We can order this original scientific calculator. And we have Casio MS. We have what? We have Casio FX 981 MS number 1, which will it costs 55,000 shillings. And also we have Casio, which is costing 35,000 only. Then we have the number 2, which is still Casio function 981 MS. We have number 2, which we have number 1, which is costing 55,000 shillings, and we have number 2, which is costing 35,000 shillings. That is the price without the shipping costing, because shipping costing vary from 5,000 to 10,000. So don't wait. You can order this. You can order this original scientific calculator for your journey of learning. So let us go into too much details. I will give you some other announcement later. So in lecture 2, basically we focused into 2 concepts. Okay, the first one, the definition, the general formula of gamma of n. This is equal to integral from 0 to infinity, and then we have e by negative x, and then we have x n minus 1 dx. Or we can define it as the function of x, gamma of x is equal to integral, which is a special type of improper integral. So e by negative t, then we have t by n minus 1 dt. So these are the general formulas of gamma function. And then we talked to you about properties. We introduced to you about properties of of gamma function. So, and we proved it to you we proved it to you the first property of gamma function, which is gamma of n is equal to n gamma of n plus 1 is equal to n gamma of n. So that's we call the recurrence formula. So the first property we call the recurrence formula, which is gamma of n plus 1 is equal to n gamma of n. Or we can make gamma of n the subject. So we have gamma of n is equal to gamma of n plus 1 over n. And we left the homework, which was example 2. You have to refer some past papers. It's common question to prove that gamma of n plus 1 is equal to n factorial. This is the second property. So as it has been titled there, the properties of gamma function. So just to remind you, we say that when we are dealing with properties of gamma function, FCT, Okay, gamma function. We say that in gamma function there are three. In gamma function there are three basic properties. Basic properties of what? Of gamma function. So if we write this one, that means gamma function. And these properties are, we have dealt with the first property, gamma of n plus 1 is equal to m gamma of m. Then the second property, we have dealt with gamma of what? So we had gamma of n plus 1, this is equal to n factorial. And the third property which we are not going to prove, gamma of n times gamma of 1 minus n, this is equal to pi over sine of n pi. So those are the three properties. So we have already covered this one in lecture 2. So let us focus in the second property, or the second property of 40 of gamma function, which is correction of 40. So I believe that you've tried your level-based correction of homework 2. So let us focus on corrections of homework 2. Okay? Correction of homework 2. Which the questions ask us to prove. To prove that. And this is example 2 also. Prove that gamma of n plus 1 is equal to n factorial. If you succeed, you'll be rewarded 6 marks. So it's a kind of the long proof, but let us go. Are you ready for that? Okay. So the first step, so solution. You're going to follow a number of steps. The first step, we say that you have to recall what? Recall the general formula of gamma function. So it states that gamma of n is equal to integral from 0 to infinity e power negative x power n minus 1 dx. Okay. So if you consider, so it means that from gamma of n plus 1 is equal to n factorial, which is question 1. So you say that we go for the second step. We say that you have to consider right hand side of equation 1 above. Equation 1 above. So to consider the right hand side of equation 1 above, so if you apply gamma of n plus 1 is equal to integral from 0 to infinity, then you have e power x, then you have x e power n plus 1 minus 1. Because the value of n is n plus 1. Okay. So if you open the bracket, you have what? Gamma of n plus 1 is equal to integral from 0 to infinity, e power negative x, then x power n, but here we have the x, I forgot dx. Okay. So suppose that this is equation, suppose that this is equation 2. So we go for the third step, ladies and gentlemen. So we want to integrate that function, which is the finite function, but it is improper integral because it is not the finite integral, it is infinite integral. So the third step, we say that apply the formula of integration, apply formula of integration by parts to integrate what? Integrate question 1, question 2. Okay. So remember the formal definitions of what integration by parts. So the formula or formal definitions of integration by part, if it is a finite integral, so So if you integrate u dv from a to b, this is equal to what? uv from a to b minus integral from a to b. Then we have what? We have v du. Okay, v du. That's the integral that we have. Okay, so if that's the case, we say that this is question 3. Okay, so question 3 we say that let u is equal to what? X power n dv e power negative x in dx. So I say that this is du dx is equal to n xn minus 1. So for this case, we have dv e power negative x dx. Let us integrate both sides. Okay. So we did this process. If you refer lecture 2, we did this first step. So it's just a revision of what I taught you in proof of first property. So we say that on the left, there we have the u dx is equal to n x power n minus 1. So this implies what? This implies the u is equal to n x n minus 1 dx. So remember that this is a very important expression. So then we have integral of what? Of dv, which we integrate e power negative x in dx. So if you integrate dv, we get dv is equal to what? Is equal to negative e power negative x. Okay, so we go for the second one. So we go for the first step. So the first step, we say that let us substitute u and v in right hand side. So u du and v in right hand side of equation 3. So that will make it. So we say that gamma of n plus 1, which was integral from 0 to infinity, x power n e power negative x dx. This is equal to it. Is equal to u, which is x power n negative e power negative x 0 to infinity minus what? Integral from 0 to infinity. Then you have u, which is negative e power negative x. Then du it is n times x power n minus 1 dx. Right? So then we have what? So we have gamma of n plus 1 is equal to what? Is equal to, if you substitute infinity, to negative infinity power n, then e power negative infinity minus plus 0. So negative is positive, integral from 0 to infinity. We have n e power negative x power n minus 1 dx. So remember that part we taught you in lecture 1, e power negative infinity, or you can try take e power negative 1 exponent 99, the answer is equal to 0. Okay. The answer is equal to what? The answer is equal to 0. So the technique of proving these two properties of gamma function, so I say that here we have gamma of n plus 1, gamma of n plus 1, this is equal to 0. plus what? Integral from 0 to infinity. And then we say that this is m e power negative x dx. You have what? You have x n minus 1 dx. Is equal to what? Integral from 0 to infinity and e power negative x power n minus 1 dx. So take n out. So gamma of n plus 1 is equal to n. Take out of the integral and e power negative x power n minus 1 and dx. So that is the first step. So we go for the fifth step. The fifth step. So this was equation 3. So suppose that this is equation 4. So we say that apply the formula of integration by parts. Okay, integration by parts. This formula. So we have to let. So to let, the simplest way by using the concepts of I-latte. I-latte stands for I stands for inverse, L stands for logarithmic, A stands for algebraic, T stands for trigonometric, and then E stands for what? For exponential. So let U is equal to x power n minus 1. And let the V is equal to what? E power negative x dx. So find the U, differentiate U with respect to x. So this will make n minus 1. So then we have x minus 1 minus 1. Then again we have the V is equal to E power negative x dx. Integrate possibles. So the U, this is equal to n minus 1 x power n minus 2 then dx. So if you integrate, this is V is equal to it. Is equal to negative E power negative x. Okay? You get to see A power negative x. That's the value of 40 of V. And this is D. So remember that these are the important values. So for that case, we say that gamma of n plus 1 is equal to n. So then we have what? U. What is U? So negative x n minus 2. Negative x power n minus 1 e power negative x. So then this is minus so 0 to infinity. Then I have negative e and negative x. Then u it is x. No, the u dx. So the u dx it is what it is n minus 1 x power n minus 2. Yes. this is n, and here we have what? So simply we have what? We have negative infinity power n, e power negative infinity plus 0. And then negative is positive. Then we have integral from 0 to infinity, e power negative x power n minus 1 dx. But here we have what? We have n minus 1 dx. So simply this is equal to what? M, and then n minus 1 is common. We have to take it out of integral because e power negative infinity is 0. So if that's the case, so we have integral from 0 to infinity. Then you have e power negative x power n minus 1 dx. So this is what? Gamma of n plus 1 is equal to n minus 1. Then integral from 0 to infinity, e power negative x power n minus 1 dx. So this is equation 5. That is question 5. Okay? That is question 5. So if it's question 5, we go for the 6th state. The 6th state, we say that apply formula of integration by parts to integrate equation 5. Okay, so we are doing integration by part for the third time. We did for the first time as we did in the first property. We did it for the second time. We are just observing a certain property. Remember that we are just proving the second property. Gamma of n plus 1 is equal to n factorial. That's the fundamental concept and that's the fundamental question. So don't think that we are lost around. We are still going there, right? And should not get tired. You have to be encouraged because this is the beauty of higher engineering mathematics. So to apply the integration by parts formula, we have to say that for that case, we have to say let u is equal to what? Is equal to x power n minus ct minus r. This is minus 2, excuse me, n minus 2. So this is n x power n minus 2, x power n minus 2, x power n minus 2. And then you have to let dv is equal to e power negative x dx. Remember, we are using the principle of what? I naught. I stand for inverse, logarithmic, algebraic, trigonometric, exponential. So in this interval, we have two types of function. X power n minus 2 is algebraic function, so we have to let it as u. And e power negative x, the exponential function, which is natural exponential function, we have to let it as what at dv. Why are we using this principle for latter? In order to simplify life, because we as engineers, we have to design systems which simplifies lives and which solve real life problems. So the way that we have to design our systems, we need the kind of applied mathematics or the kind of the special mathematics which actually that simplifies lives. So that's why that you find we are using the informal definition, but we are still resuming the same meaning of engineering mathematics. So let us differentiate this with respect to the x u dx. Then this is n minus 2. Then this is x n minus 2 minus 1. So then we have dv. So dv is equal to e power negative x dx. So then we integrate like this. So then u is equal to n minus 2, then x n minus 3, right? Then dx. So if you integrate this one, v is equal to negative e power negative x. So these are very important information for the next interval process. Okay, I believe that you're enjoying the beauty of higher engineering, mathematics and scientific mathematics, and enjoying the beauty of gamma function, and enjoying the beauty of improper integrals, special case of improper integrals, and then change the beauty of advanced calculus. So once we have these two values, then we have to substitute into the equation 5. So gamma of n plus 1 on left hand side is equal to n minus 1. This is all about equation 5. But now we have integrated the equation 5 by using integration by parts. So we have u. Our u, it is what? It is x power n minus 2. But then we have v, it is negative e power negative x. The limits from 0 to infinity. Then minus integral from 0 to infinity. The integrand is what? For v, it is negative e power negative x. Then we have the u dx. We have the u. The u, it is n minus 2. So multiplied by what? N minus 2. Then we have what? X power n minus 3. So we have x power n minus 3. Then dx. It's minus n plus 3 dx. Okay? So then we close our curly bracket. So let us consider the right hand side. You have n minus 1. And hence you know that all of these, because of the type of the lower and upper limits, this gives us 0. Why? Because it is still negative infinity, power n minus 2. Then we have e power negative infinity, which is 0. So minus plus 0, right? So this part always will give you 0. So negative is positive, and then we have what? Here we have n minus 2. So we take it out of integral. Then this is integral from 0 to infinity. Then we have what? We have e power negative x. Then we have x power n minus 3. Then dx. So we have the curly bracket like that once. So if that's the case, you have gamma of what? Of n plus 1 is equal to n minus 1. Then this is what? So this is 0. And then plus what? N minus 2. Then we have what? So we still have what? Integral from 0 to infinity. Then we have what? We have x power n minus 3, e power negative x dx. So then we close the curly bracket. So ladies and gentlemen, here we have gamma of n plus 1. This is equal to n minus 1. Then what? N minus 2. Then we have integral from 0 to infinity. Then we have what? X power n minus 3, e power negative x, then dx. Okay. So, if you do the integration by part again, right? So listen, bear this in your mind. If you do the integration by part, so this is the first word, the seventh state. The seventh state, if you do integration, if you integrate this one, 0 to infinity, then x power n minus 3, e power negative x dx. This will give you what? N minus 3. Okay? And then what? Integral from 0 to infinity. Then you have x power n minus 4. Then e power negative x dx, etc., etc., etc. So it means that what will you find that gamma of n plus 1, because this is a duality. For example, if you integrate again x power n minus 4 times e power negative x dx from 0 to infinity, then you get n minus 4 integral from 0 to infinity x power n minus 5 times e power negative x dx. If you integrate by parts again, the integral from 0 to infinity of x power n minus 5 dx, then you will find that the answer is n minus 5 integral from 0 to infinity of x power n minus 6 e times e power negative x dx. So you do it continuously and without end. So what will you examine? So you find that gamma of n plus 1, this is equal to n times n minus 1. So then we got n minus 2. Then so this is for the first integration by part, second integration by part, third integration by part. If you do the first integration by part, you will see that you have n minus 3. And then if you do integration by parts again, 1, 2, 3, 4, 5 for the fifth time. You have n minus 4, then you have n minus 5, etc., 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 up to what you, up to gamma of 1. Okay, up to gamma of 1. So we have developed the, or by doing integration by parts, first time, second time, third time, fourth time, fifth times, 6 times, 7 times, 8 times, we can have this property now, that gamma of n plus 1, ladies and gentlemen, this is equal to n times n minus 1, then n minus 2, then n minus 3, then n minus 4, etc., etc., and the last one is gamma of 1. Okay, so gamma of 1, actually that you know that gamma of 1, yes, if you recall the formula, gamma of 1 can know it's integral from 0 to infinity, e power negative x, and then we have x in power 1 minus 1 dx. So simply this is integral from 0 to infinity, and then we find that is e power negative x, x power 0, and then 0 to dx. So you can find the response there, because the response is integral, so negative e power 2. Okay, so simply with that property, we can say that the 7th step, the 8th step, excuse me, this is 8th step. The 8th step. The 8th step, we say that we call a factorial function of 40 of n. And this is n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 times n minus 4 factorial. Okay? So if that's the case, we can substitute in what? This is question what? This is question 6. Okay? Question 6. So question 6, and this is question 7. So substitute equation 7. So substitute equation 7 in equation what? In equation 6 above. So when we substitute it, we find that the gamma of n plus 1 is equal to n minus 1, n minus 2, n minus 3, times what? N minus 4 factorial. This is equal to n factorial. So, ladies and gentlemen, the second property of gamma function, gamma of n plus 1 is equal to n factorial, and show very important property of what? Of gamma. Very important property. This is the second property of what? Of gamma function. So we have already shown that it's true that gamma of n plus 1 is equal to n factorial. So you have to remember these properties, and then let me leave you a challenge. The question was taken back to proof, hence proved. Hence proved it. Okay. So the third property is gamma of n times gamma of 1 minus n is equal to pi of what? Of the sine of n pi. So proof is left in for you. Okay. That is how the engineering mathematics is beautiful for you. Remember that to visit the online undergraduate library, where you can access the original scientific calculator of Casio function 991. Number one, it costs 55,000 Tanzania shillings, and number two, it costs 35 Tanzania shillings. But we recommend number one, which is costing 55 Tanzania shillings, and we'll use this scientific calculator more than 3 years of your education. So you can graduate your undergraduate educations and then leave it to your young brothers who will be also next after you. Okay, so we have these three properties of 40 of gamma. So let us see the applications of these three properties of 40 of gamma function. And then right now, ladies and gentlemen, let me take you into gamma function of positive integers. So as we say that the gamma function focusing on dealing with integers and fractions or non-positive integers. So we say that the gamma properties are used to evaluate gamma of integers, remains positive and the integers and what and fractions. So the gamma properties are used to evaluate gamma, to evaluate the value of gamma, to evaluate values of what of gamma, evaluate values of what of gamma of integers and what and fraction. So right now, let me take you into the first part of application of gamma properties. And this first part is all about gamma properties or gamma function of positive integers. Evaluation of values of gamma of positive integers. So let us begin with positive integers. Okay, evaluation of values of gamma of positive integers. Okay, so we say that whenever that we have to say that we have to recall the recurrence formula. Of what? Of gamma function. Gamma function of what? Okay, carries form of gamma function. We state that the gamma of n. Now, we have discussed this gamma of n plus 1. This is equal to n gamma of n. Okay? This is the property. So then now we can deal with example 3. Okay, example 3. Find gamma of 5 and the gamma of 9. That is simple question like that. Then we deal with kind of challenging. So you have to recall the second property, not recurrence. So recall property, recall secondly property of gamma function. So solution, to evaluate the value of gamma of 5, which is positive integer, the first step is just to record what? To record the second property. So that state gamma of n plus 1 is equal to n factorial. So if that's the case, you say that the gamma of 5, this is equal to what? Gamma, so expressed in n plus 1. So split 5 to become a certain number plus 1. So it means that 5 minus 1 will remain with 4. So gamma of 5 is equal to gamma of 4 plus 1. Right? So if this is the case, so suppose that this is question 1 and this is question 2. So gamma of 5 is equal to gamma of 4 plus 1. So from this property, gamma of n plus 1 is equal to n factorial. So it means that here we have gamma of 4 plus 1. So our n here is equal to 4 if you compare. N is equal to 4. So gamma of 5 is equal to gamma of 4 plus 1, which is equal to 4 factorial. And this you can use your scientific calculator, or you can find that 4 factorial is 4 times 3 times 2 times 1 factorial. So it means that this is 24. Isn't it? Yes, because 12 times, okay, it's 24. So it means that simply, therefore, gamma of 5 is equal to what? 24. That's the response. Don't expect that you'll find questions of evaluating gamma of 5 in exam. But this is a foundation. So this we are going to use. This is the subpart of the long questions that we are going to solve in gamma intervals. So it means that we'll be solving a question following maybe 5 steps, and then the last step, in order to achieve and find the value of the particular interval by using gamma function, then we apply the third property, which is gamma of 5 is equal to 4 factorial. So second step, we have been asked to find the gamma of what? Of 9. So you have to just record the second property, which will prove the gamma of n plus 1 is equal to n factorial. Right? So if that's the case, so we say that we have to express gamma of 9 in terms of what? The gamma of n plus 1. So gamma of 9 is equal to gamma of 8 plus what? 1. So what is n? N is equal to 8. So this is 8 factorial. So you can use 8 times 7 times 6 times 5 times 4, or you can use your scientific calculator, but 850 factorial. The answer is 40,320. 40,320. So therefore, gamma of 9, this is equal to 40,320. Okay, so that's a straight way of using the second property from solving or evaluating the gamma or the values of gamma of positive integers. But let us see a little bit challenging concept. At example 4. Question asks us that given gamma of 10, so given gamma of 10 is equal to what? 362,880, like this. Then after you'll be given gamma of 10, find gamma of 9, find gamma of 9, and also find gamma of 8. So 10 is positive integer, 8 is positive integer, 9 is positive integer. So what does this question mean? It means that you have to find gamma of the given positive integers by using what we've been given. So we should not find by using the property. We have to use the property or use any other technique. It means that we should not find, according to this question, we are not allowed to find gamma of 9, which is equal to 8 factorial. And we are not allowed to find gamma of 8, which is 7 factorial. For this case, we have to see how do we apply these concepts of gamma of 10, right? So you have to be careful. So solution. It's a simple question, but if you don't understand the trick, then you can get lost along the way. Solution. So gamma of 10. So remember that we have that property. So remember that. Recall we say that gamma of n plus 1 is equal to n factorial. But also we can have the first property, gamma of n plus 1 is equal to n gamma of n. That's the best. Okay? So if that's the case, for example, we'll be given gamma of 10. So gamma of 10, this is equal to what? Gamma of 10, this is equal to gamma of 9 plus 1. So it's equal to gamma of 9 plus 1. And then this one is equal to what? So it's equal to n. So if you compare, n is equal to 9. So we have 9 gamma of n, which is 9. Okay, all right? So gamma of 10 is equal to 9 gamma of 9. The question is being asked to find gamma of 9. And this is question 1. We go for question 2. So question 1. So from the question 1, we have gamma of 10 is equal to 9 gamma of 9. So we are looking at gamma of 9. So divide by 9, divide by 9. So ladies and gentlemen, gamma of 9 is equal to gamma of 10 over 9. So what is gamma of 10? So gamma of 10 will be given that 362,880 divided by what? By 9. So gamma of 9. So you're allowed to use your scientific calculator there to do that division. So you have 362,880 over 9. So it is 40,320, which is this. So that's the response for what you have been asked in the first part of the question. The second part of the question, you have to use the same trick to find gamma of 8. How do we find the gamma of 8? Okay? So this is the second step. To find the gamma of 8, we have to go for the third step. Third step, so that gamma of what? Of 9, this is equal to gamma of 8 plus 1. So from the property that gamma of n plus 1 is equal to n gamma of n. Okay? So either the case that we say that gamma of what? Of 8 plus 1 is equal to 8 gamma of what? Of 8. So looking gamma of 8. So you divide by 8 and this one divide by 8. So then we find that what gamma of 8 is equal to gamma of 8 plus 1, which is equal to gamma of 9 over 8. So then what is gamma of 9? Is 40,320 over what? Over 8. So the response have to divide by 8. Answer is 5,000. So therefore, gamma of 8 is equal to 5,000 5,040. So gamma of 8 is 5,040. Okay? That's the gamma of 40 of 8. So it means that gamma of n positive integer, you have just to use the properties of gamma. So gamma, for example, if you be asked that the gamma of what? If you ask that, find the gamma of 22. So you know the gamma of 22 just simply is equal to 21 factorial. If you be asked maybe gamma of 33. So gamma of 33 is equal to 32 factorial. That's the principle. You have to remember it. Okay, so that's all about gamma of 14. So let me leave the homework for you. Homework, which is homework 3. Find gamma of 20 and also find gamma of 25, of 35. Simple. So this is example 5. Because you have example 1, 2, 3, 4, 5. So let us focus right now. Let me end with this session at evaluation. Evaluation of what? Of values of what? Evaluations of values of gamma, which is does not have any application. Gamma of negative integer. Negative integers. Negative integers. Negative integers. So you have to focus on how we can deal with gamma of negative integers and what the limitations of these gamma properties. You have to understand this. First of all, you have to note gamma of negative 1 is equal to infinity. No, gamma of 0. Excuse me. Gamma of 0. Gamma of 0 is equal to infinity. Gamma of 0 is equal to what? Infinity. Gamma of 0 is equal to infinity. Gamma of 0 is equal to infinity. So, bear that. Example 6. Let me teach you this concept by using examples. Find gamma of negative 1. Gamma of negative 1. Then let us find gamma of negative 2. And then let us find gamma of what? Of negative 5. Negative 5. Then let us find gamma of negative 6. And then this will be a homework. Find gamma of negative 11. This is your homework. I will teach you the other 4, but your homework will be the first part. Okay, so solution. solution, you say that we have to evaluate year number.
So the first is